we're going to start talking about stateful APIs today. When we talk about state in general in programming, we talk about the concept of some things collecting data. So they retain data about something. A simple example could just be a class object that has some fields, and the fields, they contain some values. So you can refer to the fields and then take the values out. And the same thing can be said about an API. So in this instance, we have a list of open WebSocket connections. You see, that's the cool thing about the WebSockets is you don't lose the connection. So we have all of these open connections. So when clients, they start sending messages to the server, we just add them to this list. So we are keeping state of connections, which means that one client sending a message to the server can impact another client that is sending a message to the server. So what we're going to be building is just a little chat system. So when clients send messages, instead of broadcasting to everyone or just getting the message back to themselves, they should be able to send messages to whoever is in the same room as themselves. So we're going to change this one right here. And we're going to make a class, we can just call it state service. You could also call it something like WebSocket state service if you have multiple types of state. You could make this as a singleton object, and then inside of your program CS file, just require this as a singleton. So you can go like builder, services, add singleton, and then take whatever state you have, and then inject this into other places where you might need the data about the WebSockets. Personally, what I like to do is take the state service and just make it static. This does introduce some new problems, but it also solves some other problems. We can get back to that later. And instead of having a list here, I want to have a dictionary. And the dictionary here refers to the IDs of the connection and then the connection object itself. So I'm going to just make a public static dictionary containing a GUID and an iWebSocket connection. And I'm going to call this one connections. And then just write new here. So where does this GUID come from? Well, when you have a WebSocket connection with Fleck, what you essentially have is a bunch of metadata about the connection as well. So right here, our WS variable here contains something called connection info. And then there is something called ID here. And the ID is a GUID. So we'll just make a new function inside of the state service to add this connection to the dictionary. State service, add connection, and then just put in the WS variable here and create a method. And it has to be static because I declared the class as being static. And the way you add things to a dictionary is just by saying connections, try, add, and then take GUID and then the WebSocket itself. So the first argument is WS, connection info ID. The second argument is the WebSocket itself. It should be noted that the try-add method actually has a return type that we're not using. So you could say this should return a bool and then write return here. Then you can always have a boolean describing whether or not it was successfully added. And now in order to actually group these together in rooms, what we have to do is we have to create another dictionary. So we start out the same way, public static dictionary. And then the key here is now the integer referring to the ID of the chat room. So each room will just be like 1, 2, 3, 4 or whatever. And then the value here in the dictionary is a hash set of all of the GUIDs. So essentially what you're going to have is this dictionary here is the single source of truth for the actual connections. This here just refers to what connections are inside of this room here. There are other ways you could do it. You could use a concurrent bag or something as simple as a list, but we care a lot about performance. So a hash set has really fast lookup times. Dictionaries themselves have really fast lookup times. So this makes sense. And then we can just call this rooms and just make a new here. So you don't have to specify the type in new or C#. So let's say that a client wants to enter a room. What they essentially do is they just add their GUID to the hash set of an existing room, and if the room doesn't exist, we'll just create one for them. So I'll make a method here, public static void add to room, and then I'll just take a WebSocket connection here, and I'll make an int called room, and I'll just scroll down a little bit like this and give this a name. And now we will implement this method. So first we'll just figure out if there already is a room with the specified ID. So we'll just write if rooms contains key, and then just take the integer value here, room, so just refers to a simple integer. And if it does not contain the key, then just add a new hash set to the rooms. So rooms add new hash set of GUID. And we have to specify what the key is supposed to be, and that is supposed to be the room. So add the room key, add a new empty GUID, and now we throw the actual GUID inside of that room. So rooms, and then the key, room, add, and then WebSocket connection info ID. And of course, once they have entered the room, they should be able to broadcast to that specific room. So I'm gonna make so I'll just make a third static void here, public static void, broadcast to room, and then we take the int room, and then we take a message. So you could just be like string message. So what we're gonna do is we're gonna go over each GUID in the room, and then we're gonna broadcast to the WebSockets that can be looked up by the GUID. So I know this seems like a funny way of doing things, like looking up here and then going here, but because the lookup times are so fast, this is actually a very performant way of doing it. We will only broadcast to the room if the room actually exists. So we can try and figure out first and foremost, does the room exist? So var does room exist equals rooms try get value, and then take the room ID here. We actually have a second argument here, which is going to be able to contain the hash set of the GUIDs if they exist. So if you write out var GUIDs, here you can see in the inlay hint that it says hash set of GUID. So I will make an if statement here, if does room exist. Now we'll just iterate over all of the GUIDs. So we'll just write for each var GUID in GUIDs. So inside of the loop here, we'll basically be doing the same thing, but instead of using try get value on the rooms, we'll just do connections. So connections try get value GUID out var, and then specify a name for whatever WebSocket connection, out var WebSocket. So you can also give this one a variable if you want to, or you can just write if straight away here, if try get value. So if you get the WebSocket connection out, WebSocket send, and then take the message up here. And that's basically it. We can also make this slightly more clean by doing like this, and then saying if here, and then wrapping this one inside of the if statement. So let's build some events that can actually make use of these methods here. So what I'm gonna do is add a new class that is the event handler. A client wants to enter room.cs. So in here we will of course extend the base event handler class, which must take in a transfer object, which extends the base DCO class. So I'll make a new class here, public class, just call it the same name, DCO, extends base DCO. For now, all we need is an int which refers to the room ID, and we'll just make this a property and put the DTO class into room DTO here. and then just implement the missing member. Scroll down a little bit, and now we don't actually have to inject the state service, because the state service is static, so we can just call it right away. State service add to room, and they will just take the WebSocket connection, so it refers to this one here. We have to call it socket then, and then take the room ID, so DTO room ID, and then here return task dot completed task. So that's actually it. Like you could make like a counter event. In fact, I'll just do that straight away. So the client is getting a message back from the server. Server adds client to room, and then I'll just make a message here, public string message. Take the WebSocket connection, send JSON serializer. I use systemtext.json, it's the built-in library. And then just make a new class object here, server adds client to room. And you can put in a message here, like, you were successfully added to room with ID, DTO room ID. So of course, in a more realistic setting, you would first figure out if they were successfully added. So this one here, we could actually turn into a Boolean that refers to the success of adding them to the room, because the Boolean here actually returns true or false if it's already present. So you could write return here, and then say var is success, if you want to do that, and then you evaluate whether or not they were already in the room. But that's kind of besides the point. So now we can enter the room, and now we just need one method to broadcast to the room. So add a new class here. Client wants to broadcast to room.cs. And we will basically just do the same thing. And I'll try to be somewhat fast here. Public class, DTO, extends base DTO. And now we'll just make a message here. Public string message, get set, and public int room ID. So it's the room ID that they want to broadcast to. Client wants to broadcast to room, DTO. And then implement the missing members. And now we just call the broadcast method. State service broadcast room, take in the DTO.room ID, and then just whatever string we want to send here. So DTO dot I just entered the wrong class here. DTO.message. Return task.completed task. And we're actually ready to try this now. Before we get too far, I also want to note that you should be using async await here, and then also logging whatever exceptions you're catching. So this here is essentially a global exception handler that just logs to the console. So you could also make messages return back to the client under some circumstances. But right now, we're just interested in figuring out if anything goes wrong, what's actually going wrong. So I'll just add a little bit of information here to actually be able to figure out if anything goes wrong. So here we have Postman, and we are ready to connect to the WebSocket server. And now we have already been added to the list of open connections, but we are not in a room yet. But if we send this enter room event here, we will now enter the room with ID 1. And we were successfully added to the room with ID 1. So there's a little response here. We didn't actually need the response to be added to the room, but it's nice to have. And now we want to send a message to the room. And I actually called it broadcast to room. So client wants to broadcast to room. And then there should be a message here. So send. And now it says, hey buddies. And of course, we're interested in figuring out, does the broadcasting actually work? So we'll take another connection here, and then we'll just try and enter room and send message to room. So this is the exact same request here. And we have now gotten 2 hey buddies. So we can see that we actually, we're getting this message correctly broadcasted. So one of the common use cases of making stateful APIs is, of course, you want to associate some data with the connections, because right now a connection is just a GUID. So up here, I'll just create a class here, public class, WebSocket metadata. So the WebSocket metadata is supposed to be able to hold a WebSocket connection and then something associated with it. So I'll just make a primary constructor here, iWebSocket connection, and then I'll make a property here, public iWebSocket connection, get set, and set this equals to the connection from the primary constructor. And then I could hold some data like the name of the user. So public string username, get set. So the idea is that before they enter the room now, they must assign themselves a username. And then when we send the message, we can send the username along with the message. So now there is data about the user. So this is, of course, a very simple example where we just have one property that is associated with the WebSocket connection. But we'll start with this one. Now, instead of having a GUID here and a WebSocket connection, we'll just put the WebSocket metadata class here. WebSocket metadata. Or WebSocket with metadata, maybe. This is slightly more descriptive. And now we'll just add in the WebSocket with metadata object here. New WebSocket with metadata. Just go a line down. Because we have a constructor here, we don't actually need to do something else. Just make a new object and put this object in here. The same here can be said for accessing the connection. So that's actually it. We don't have to do anything more. So we'll make a fake sign in where you assign yourself a username. Let's make the sign in event here. Client wants to sign in .cs. And like I mentioned, this is just like a fake sign in where you just assign a name. Public class, take the same name here, DTO, base DTO, public string username, get set. Implement the missing members, scroll down a little bit, close the panel, and now we will just change the username. So a very fast way of assigning the username is simply just to go to the state service, go to the connections, find the connection with the WebSocket connection ID that we have here. So this is the current client sending this. And then just take the username and say dto.username. You could send a counter event like, hey, your username has been sent. We don't really care about that for now. Return task dot completed task. And now when we get around to broadcasting, broadcast, client wants to broadcast the room. I'll make a class here. Public class, server broadcasts message with username. Extend space detail. Public string message gets set public string username, get set. And now this broadcast room here will actually just take in this object here, var message equals server broadcast message with username, use the new keyword, and then just put in the message here, and then put in the username, which comes from the socket state, state service connections. Open up whatever GUID we have here, socket connection info ID dot username. So now we have a perfect little object here, and we'll just serialize this, JSON serialize, and now put in the message. So that's actually it. We don't need to do anything more than that. Run it again. So here is the big reveal, right? Start adding the connection. So now we're in the dictionary of WebSocket connections. Authenticate. Currently, when we sign in, we don't get like a counter event, but that doesn't matter. Enter room and then broadcast to the room. And here is the moment of truth. What are we getting back? We're getting back the hey buddies message with the username we specified. So we are successful with grouping our WebSocket connections and also associating other data with the connections, such as usernames or user IDs or whatever you want to have. So it's all good. In the next video, we'll start talking about how we can test WebSocket systems.